Today's video is 6.4, solving exponential and logarithmic equations. So we're going to start off, I want you to think about something. Suppose that 3 to the x equals 3 to the 5. What do you think that x equals in this problem? So just think for a moment, what do you have written here? You have the same number on both sides, just different exponents. And you're trying to solve for x, essentially. So because you're trying to solve for x, well, if these have the same base, then it should be pretty clear that x equals 5. Because you can plug 5 back in for x, and you find that both sides equal each other. And that's the whole idea of algebra, right, is to make sure that both sides equal each other. So x equals 5. So think for a moment, what do you think x would equal in this problem right here? We have 5 raised to the power of x plus 1 equals 5 to the power of 9. So think for a moment. So if you thought setting x plus 1 equal to 9 is the way to go, you are correct. You could probably even do that in your head at this point. And so x would equal 8, because 8 plus 1 is 9. So keep this in mind as we go through solving exponential equations. So I'm going to show you how to solve an exponential equation. We have 4 to the power of x equals 1/2, and the 1/2 is raised to the power of x minus 3. What we want to have happen is we want to have both sides have the same base, like we saw in the last piece of paper. So what I notice is that we have a 4 and we have a 1/2, and I think it's possible to express 4 and 1/2 as 2 raised to some power. So let's start with the 4. Well, we know that 4 is 2 to the power of 2. Well, so we'll come back to that in a second, but we're going to use this idea in this problem. And then we have 1/2, and we can raise 1/2. Well, we learned in section 6.2 that you can rewrite this as 1 over 2 to the power of 1, which means that you can rewrite this as 2 to the negative 1. So we're going to use that idea as well. So we want to use both of these to slightly rewrite our problem. So we have 4 to the power of x. We're going to replace the 4 with 2 squared, but when you do that, you need to use parentheses around what you're replacing. So I'm going to put 2 squared instead of 4. I'm going to put the parentheses here, and then the power of x should go on the outside like this. Okay, bring down the equal sign. We're also going to replace 1/2 with 2 to the negative 1. Also inside parentheses, leaving the x minus 3 on the outside of the parentheses. Now, you cannot yet do what we did in the last slide. What we need to do is combine our exponents on both sides. So if you recall, if you have a power raised to a power, like we have 2, like this little 2 to the power of x, you multiply the exponents together. So you keep the big 2, but you do 2 times x is 2x. Okay, so I just multiplied my exponents. You bring down equal sign. Now, how are we going to do this on this side? Because we have a negative 1, but then we have a binomial here. We have x minus 3. What we're going to do is we're going to take that and distribute the negative 1 onto both terms. So we're going to keep the big 2. This 2 right here comes down. But let's go ahead and distribute this negative 1 onto x minus 3. Well, remember, distribution means I need to multiply negative 1 to both of these. So negative 1 times x is negative x. Negative 1 times negative 3 is positive 3. Now we're at that situation, like we saw in the previous slide, that we can set the exponents equal to each other. We can set 2x equal to negative x plus 3. Because both sides of the equation have the same base. That's all it is. And we can solve for x from here. It's pretty easy. I think the easiest way to go about it would be to add x to both sides. So those reduce to 0. 2x plus 1x is 3x. Bring down the equal sign. We have a positive 3 left over here. And so x equals 1. And that's your answer. Okay. Let's do another one. Let's go ahead and do this one. So we're going to solve this exponential equation. We have 9 raised to the power of 2x equals 27 raised to the power of x minus 1. So think about, can you write 9 and 27 as a common base with different exponents? Well, here's what we know about 9. We know that 9 is 3 squared, and 27 is 3 cubed. So I think it's safe to say that we can apply the same thing we did in the last slide onto this problem as well. So we're going to replace 9 with 3 squared, putting it in parentheses, and keeping the other power that was already there on the outside. Replace 27 with 3 cubed, put the x minus 1 on the outside. Now multiply your powers on both sides. 2 times 2x, we're going to have 3 to the power of 4x. Equal sign. We're going to have to distribute in this problem as well. And by the way, not every problem requires distribution. It's just that both the examples I'm doing just so happen to have distribution required. So 3 times x is 3x. 3 times negative 1 is negative 3. So we're at that point that we can set both exponents equal to each other because our bases match. So we're going to set 4x equal to 3x minus 3. And to solve for x, I think the easiest way would be to just subtract 3x from both sides. So these reduce right here. But when you do to one side, you got to do it to the other. 4x minus 3x is just x. Negative 3 comes down, and that's your answer. Okay? So here's a couple more exponential equations. Sorry for the focus. I do say recall log base b of b to the power of x is equal to x. We saw this happen a lot in section 6.2. This happened a lot in section 6.2. Now here, if you look at number 1, we have 4x equals 11. Now we could take 4 and write it as 2 squared, but can we do anything with 11? Actually, 11's prime, and so you can't do anything with this problem. So what do you do if you cannot do what we just did in the last 2 problems? This is where logarithms come into play. So if you cannot do that, we're going to have to use logarithms. I'll just say logs. So here's what you do. We want to get x not as an exponent, but we want to bring x down from the exponent position down so it's no longer an exponent. The way to do that is to take the logarithm of both sides of the equation. So we're going to take log, and we're going to choose base 4. And you'll see why in a second. It'll make sense in a second. But we're going to take log base 4 of both sides. So the 4 to the power of x is still here, but we're taking the log base 4 of it. And what we do to one side, we do to the other. So we're going to take log base 4 of 11 as well. Okay? So kind of process what we just did there. If you cover up the logs, we have the same equation still. It's just that we're taking the log base 4 of both sides. Well, what happens with the left side? The left side, this property happens. Remember that if the base and this number match, this just becomes whatever your exponent is. And what is your exponent? It's x itself. So this whole left side, because of this property, becomes x. Bring down the equal sign, and then we just need to take log base 4 of 11. Let me just grab my calculator real quick. So how do we do log base 4 of 11 into our calculator? We have to rewrite this slightly, because remember, our calculator only has base 10 button, but we're right now in base 4. So we're going to rewrite this as log 11 over log 4. This will change the base to 10. And now we can just plug this right into our calculator. Turn the calculator on. And we're going to type in log 11 divided by log 4. And so our answer, we're going to say that, and we're going to round to 2 places, by the way. X equals 1.73. What that means is if you plug 1.73 back in for x, 4 raised to the power of 1.73 It's just about 11. Remember, it's just about because we rounded in our problem. We can do the same thing in number 2 as well. We're going to take log base 12 of both sides. Because 12 and 5, we can't make a common base. Alright, so we take log base 12 of both sides. What happens on the left side is this whole thing becomes our exponent. Now our exponent is not just x anymore. Our exponent is x plus 2. So we're going to bring x plus 2 down. And then we have log. And this is base 12. So what I'm going to do is, at the same time that this becomes just x plus 2, I'm going to rewrite this side as log 5 divided by log 12. Remember, that's our change of base formula. Let's go ahead and right now figure out what is log 5 divided by log 12. So we have log 5 division log 12. So let's go ahead and bring the x plus 2 down. And we're going to rewrite this as the decimal that it is, which is 0.65 if we round. And then we're just going to subtract 2 from both sides to solve for x. So if I do 0.65 minus 2, I get negative 1.35. Alright? And your answer might be slightly differently depending on how you did your calculator. So if you're off by like 1 right here, that's fine. It'll be acceptable. Shouldn't be too big of a deal. Alright. There's a couple more questions, or problems I need to show you. The ones that we just did were exponential equations, where x was in the exponent. But you can actually solve logarithmic equations as well. So we're going to do these two, and then this will be the end. So we're going to start with number 1. We have log base 4 of 5x minus 1 equals 3. Remember, our goal always with solving is to solve for x. Just want to get x by itself. Well, let's go ahead and, first off, we have the logarithm already isolated. So what we're going to do is we just want to write this so that it's no longer in logarithmic form. So we want to rewrite, and you might want to make a note of this real quick, rewrite into exponential form. If you recall how to do that, how do you rewrite a logarithm into exponential form? My trick that I like to use, and whatever you need to do, is you take the 4, the base, and raise it to the power of the other side, so 4 to the power of 3. And then equals whatever you have here, which is 5x minus 1. Okay, take a moment to process that. I took the base 4, raised it to the power of the other side, so I have 4 to the power of 3, equals whatever I'm left over with right here, which is 5x minus 1. Well, I think solving for x is pretty simple from here. We'll just go through it real quick. Go by your order of operations. 4 cubed is 64. So we're just going to replace 4 cubed with 64. We're going to go ahead and add 1 to both sides so that these reduce. We have 5x left over on this side. 64 plus 1 is 65. And then the last step is to divide by 5. If you divide by 5, I'm going to go ahead and use my calculator. I don't want to do it wrong mentally and then you guys make fun of me later on, because that's mean, okay? So x equals 13. There you go. And here's the last one. We have number 2. Now this one has, first off, it has 2 x's, and it has 2 logarithms on each x. So this is an interesting problem. And now it's equal to 0 as well. So that's another interesting thing. I want you to notice that this one, this logarithm has a minus sign on it. So you know what we can do? And I don't know if you realize this, and this will be the time to tell you, but we can treat this logarithm as a single entity, as a single quantity, some people might say. And what that means is we could take this and add log base 3 of x plus 4 to both sides of the equation. You try and fit this in here. You'll see why I'm doing this in a second. It's pretty cool. Now, what happens on this side is these both reduce. They're both gone. Now, we're left with this logarithm. We're going to go ahead and just bring that down. This is gone. Bring on the equal sign. Then we have 0 plus this logarithm. Well, 0 plus anything is itself, so we're going to just have log base 3 of x plus 4. Now, I want you to notice something. If you look at both sides of this equation, if you just ignore the x plus 4 and the 2x minus 1, you have log base 3 of both sides. Think about how algebra works. Algebra, what you do to one side, you do to the other. That includes undoing things. So if I want to undo a log base 3 on this side, I need to be able to undo a log base 3 of this side. Can I do that in this problem? Yeah, because both sides have log base 3. So what we're going to do is, these are gone. We can go ahead and just simply remove them. But what does that leave us with? Well, the insides. And this becomes a very simple problem. 2x minus 1 equals x plus 4. And you should know how to solve this one. I'm just going to go ahead and go through it now. We're going to go ahead and add 1 to both sides and subtract x from both sides. Because I want to move my x's this way and my numbers this way. So these are gone, these are gone. On this side, 2x minus x is x. So this is looking good. This looks like it's starting to solve itself. 4 plus 1 is 5. And that's your answer. I'm going to give a shout out to, I had a request shout out to period 4, especially Raina. So there you go. Yeah, I don't have a math joke. I'm sorry, guys. Yeah, I can't think of anything off the top of my head. I should have been more prepared. I apologize.